I wanted to do a couple more examples for you for the half angle formulas. So remember that our half angle formulas again are sine of x is equal to plus or minus square root of 1 minus cosine 2x over 2. Cosine of x is plus or minus square root of 1 plus cosine 2x over 2. Again, you don't always leave the plus or minus out in front. You choose either plus or minus depending upon where the x is here, which quadrant that x is in. Okay, that's important. Also notice that whatever this x is here, when you're using the formula, you're going to double it when you plug it in here. So let's do a couple of extra examples here. Pardon me. So let's say you wanted to do sine of 195 degrees. And I want to use the half angle formula to do this. So to use the half angle formula, I would use, well, I have plus or minus square root of 1 minus cosine of 2 times 195 is 390, and that's all over 2. Now I have to make a decision on which quadrant that 195 is so that I know that what I'm using plus or am I using minus. So thinking about quadrants here, this is 180 degrees, so 195 would be here. So this is quadrant 3 that we're talking about. Since we're talking about quadrant 3, I want to use the negative so I get rid of the positive. Okay, again, that's important. We have to make a decision on whether or not we're using the positive or the negative. So this is now negative square root of 1 minus something over 2. I've got to figure out what that cosine of 390 is. All right, so again, thinking about 390 degrees. 390 degrees, well, all the way around is 360. So 390 is another 30 past. Okay, so this will be the same thing as cosine of 30 degrees. So this is negative square root of 1 minus root 3 over 2 over 2. So that shows how we can use the half angle formula to calculate a exact value of the trig function, a sine of an angle here. That's not one that we would typically remember. Let's do another one. Let's say we wanted to do cosine. So we want to do cosine of 13 pi over, well, let's not do 13 pi over 12 because that's the same thing. Let's say we want to do negative 11 pi over 12. So, again, using our half angle formula, plus or minus goes out in front, but again, we have to make a decision on which it is. Square root of 1 plus cosine of, remember again, we double what's in here to put it over here. So this will be negative 11 pi over 6 all over 2. Let's look at negative 11 pi over 12. Usually I do that in a different color, but we're going to leave it in black now. All the way, if I go this way, all the way to here, that would be negative pi. That's the same thing as negative 12 pi over 12. So if I went negative 11 pi over 12, that's just short, right? So this is still in over here in quadrant 3. Since we're in quadrant 3, we will use the negative for the cosine rather than the positive. So we'll get rid of that. Okay. So now we're ready to do this. This is going to be negative square root of 1 plus something over 2. I got to figure out what the cosine of 11 pi over 6 is. Well, it's a pi over 6 angle, so I know we're going to have a square root of 3 over 2 for the cosine. And now let's think about where 11 pi over 6 is, negative 11 pi over 6 is. Well, if I went all all the way around, that would be negative 2 pi, which would be negative 12 pi over 6. So a negative 11 pi over 6 is just short. So I'm in quadrant 1, so that would be positive root 3 over 2. So we're done with that particular answer. All right, let's do one more type of problem that we talked about in class this morning. So let's say we are given, say we know that let's say tangent of alpha is negative, let's say 9 over 40, and that alpha is between pi over 2 and pi. So before we do anything else, let's say let's use our knowledge of right triangles to figure out where we would draw this triangle, or draw our knowledge of the signs of where the trig functions are and where we draw this right triangle. Pi over 2 to pi is quadrant 2. So I'll draw my triangle over here in quadrant 2. Here's my alpha. My opposite side here will be negative 9. This is, remember, tangent's opposite over adjacent. My adjacent side, oops, does not mean negative 9, sorry. The opposite side's a positive 9. It's above the x-axis. My adjacent side is negative 40. Okay. Do opposite over adjacent, it's above the x-axis, so that's a positive 9. To the left of the x-axis is negative 40. I won't go through the work, but if you go through your Pythagorean theorem, you'll get 41 for the hypotenuse. Okay. So let's see if we can use this triangle now to solve some different problems. Let's say you wanted to do sine of 2 alpha, for instance. Sine of 2 alpha using our formula would be 2 sine alpha cosine alpha. That's our double angle formula for sine. Looking at the triangle, sine of alpha is 9 over 41, and cosine of alpha is negative 40 over 41. And you could simplify your arithmetic if you want to, but as far as I'm concerned, that's a perfectly acceptable answer. Could do the same thing for cosine of 2 alpha. One of the ways to write cosine of 2 alpha is cosine squared alpha minus sine squared alpha. Cosine alpha again is negative 40 over 41. Sine of alpha is 9 over 41. So we get negative 40 over 41 squared minus 9 over 41 squared. And again, you could simplify the arithmetic, but this is perfectly acceptable for our purposes. All right, let's do half angles. Let's say you wanted to do sine of alpha over 2. Using our half angle identity again, that's plus or minus cosine of alpha over 2. Remember again, what goes inside the cosine here is double what's inside the sine here. So when I multiply alpha over 2 by 2, I just get an alpha. We need to make a decision on whether or not we use a plus or a minus. So going back up here, we have pi over 2 is less than alpha is less than pi. If I divide everything by 2, I get that alpha is in between pi over 4 and pi over 2. So this tells me that we're in quadrant 1. Since we're in quadrant 1, I don't worry about the negative. To finish this off then, we get 1 minus. We just said that cosine of alpha is negative 40 over 41, all over 2. And again, I do not care if you simplify that. Finally, if we wanted to do cosine of alpha over 2, same idea. We just have a plus sign in the middle. So we have plus or minus square root of 1 plus cosine of alpha over 2. Again, I need to know what quadrant alpha over 2 is in, but we already said it was in quadrant 1. Cosine is positive in quadrant 1, so we get rid of the negative. And like I've said about 4 times now, we've already evaluated what cosine of alpha is. So we plug it in and we're done. So hopefully these extra examples give you a little bit about how a little bit more of an idea of how we can use the double angle formulas and half angle formulas to solve some problems. Again, feel free to reach out to me if you've got questions. On Friday, again, for class time, I'm just going to treat it like it's an office hour. You can come ask me questions about the take-home quiz. And again, the take-home quiz is due on Friday at 5.